different types of friction. Friction can be classified into different categories based upon the criteria. If I consider the state that can be classified into two categories. First one is static friction. Second one is dynamic friction or kinetic friction. When I consider the state, that means whether the object is under the state of rest or it is under uniform motion. If I consider that state, so friction can be classified into mainly two categories. First one is static friction, second one is kinetic friction. As the name indicates, static friction, the object will be always in the state of rest. Okay, it is the frictional force experienced when the object is under the state of rest. When the object is under uniform motion, the frictional force experienced is called dynamic friction or kinetic friction. Again, kinetic friction can be classified into two categories. First one is sliding friction. And second one is rolling friction. When an object on an inclined plane is sliding downwards, so there the friction experienced is nothing but sliding friction. On a surface, if a wheel is rolling over that, there the friction experienced is nothing but rolling friction. So when I consider sliding friction, so the object is, if I apply force P in this direction, the object will be having motion in this direction. So then the frictional force will be in the opposite direction. This is in the case of a sliding friction, but it is different in rolling friction. How it is different means, here this is the wheel. I am applying force P in this direction. When I apply force P in this direction, at this point it will be like this. At this point it is vertically downwards. At this point it is in this direction. That means the wheel is rotating in this direction. So at this point the motion is in this direction. So therefore the frictional force will be opposite in this direction. Here if you observe, the applied force is along positive x-axis and the frictional force is also along positive x-axis. So that is the difference between sliding friction and rolling friction. When the surface is experiencing friction without any lubricant, so that one is called as dry friction. So in vehicles, if we doesn't provide a lubrication, so there the friction experienced is nothing but dry friction, and the friction is fluid friction. So this is the friction experienced in the presence of fluid. Suppose if someone diving into the air, so there the friction experienced is nothing but fluid friction. There the fluid is air. If someone is swimming in water, so that is also fluid friction. There is a friction between the man and the water. So that is nothing but fluid friction. So let's see the definition for coefficient of friction. We know the relation F is equal to mu into N, where F is the frictional force, mu is coefficient of friction and N is normal reaction. From that, mu is equal to F by N. So in terms of definition, I can define a coefficient of friction like this. It is nothing but, coefficient of friction is nothing but the ratio of limiting frictional force to normal reaction. Coefficient of friction is nothing but the ratio of limiting frictional force to normal reaction. You may ask, what are the units for coefficient of friction? Force is in terms of newtons. Here force, frictional force is in terms of newtons, and a normal reaction, so that is also in terms of newtons. Newtons will get cancelled. So there are no units for coefficient of friction. So for explaining angle of friction, I have considered the same example. So a wooden block which is on a horizontal surface. So I have drawn free body diagram for that. So P is the applied force, F is the frictional force which is opposite to direction of motion, W is the weight of the block, and N is the normal reaction. So I can replace these two forces, which are nothing but normal reaction and frictional force, by means of a single force which is nothing but resultant of these two. So let us consider R is the resultant of these two forces. Then the angle between the normal reaction and the resultant of normal reaction and frictional force, that is called as angle of friction, which is denoted by the letter phi. Once again, angle of friction is nothing but the angle made by normal reaction with the resultant of normal reaction and frictional force. let's see what is the relation between coefficient of friction and angle of friction. So here I am considering the three concurrent forces here, a normal reaction, resultant and frictional force. So when I form a triangle with those three forces, how it will be? So frictional force acting in this direction, normal reaction like this. These two are acting as the adjacent sides of a triangle taken in order from tail to head fashion. Then the closing side of the triangle will represent the resultant in the opposite direction, right? So what is the angle between normal reaction and resultant? So it is nothing but phi. So this is in the form of a right angle triangle. So let us consider this is A, this is B, this is C. From that, what is the value of tan phi? Tan phi is nothing but opposite side by adjacent side, right? So opposite side is F, adjacent side is N. So we know that frictional force is nothing but the product of coefficient of friction and normal reaction, which is nothing but mu into N divided by N. So Nn gets cancelled, so that is equal to mu. From that, so we can derive, we have derived the relation mu v equal to tan phi. The coefficient of friction is equal to tan of angle of friction.